Let's get into some Yahtzee or die counting kind of options. Here in Yahtzee, I think you have 5 die. I'm only going to do 3 die, but you can take these patterns into however many die you want. Okay, so let's imagine you've got 3 dice and you roll them simultaneously. That means all at the same time. And the number that appears, we will investigate some of these situations. What's the probability that all 3 die will be different than each other? Okay, so imagine die 1, whatever one that happens to be. We originally have 6 options. Let's choose one of them. If all of the options are going to be different than each other, die 2 only has 5 options. We'll choose one of them. Die 3 has 4 options. 4 options. We will choose one of them. In total, each die has 6 options, so we'll multiply 6 by itself 3 times. This is 6 per mute 3, okay, it's another way of saying this, out of 6 to the power 3. There are 55.5, repeat, percent chance that this will happen. Okay, so what about the probability that all die are the same number? Well, again, you could count it directly. You should be able to see how it should be 6 choose 1, 1 choose 1, 1 choose 1. Or another way of thinking about it is to use the law of complement. Here in part A, we've looked at none of them being the same. 1 minus, actually, I've got an error here. If I want all of them to be the same number, really it should be 6 choose 1, or 6, divided by 6 to the power 3. So that would be 1 over 6 to the power 2 for the right answer of B. Okay, what I've done isn't quite right. Okay, so what I did was try to use the complement. It seemed like a good idea at the time, where the probability of 1 minus all of them being different, I would get all the same. The reason for why that is not correct is that I could still get 2 to be the same number and not all of them to be the same number. So an incorrect solution for part B, but showing you some more ideas of what can be done here, would be 1 minus what I got in A. Okay, so even I have to be careful sometimes. C, what's the probability that someone will observe 2 6s? Okay, so 2 particular values repeated and a 5. Let me explain how you can count this. Okay, so here out of the 3 die, let's choose one of them to be the die that is different than the rest, the non-matching die. So out of the 3 die, we've got one of them not matching the rest of them, and it has one option that it's allowed to be. In this particular case, that option must be a 5. Okay, so here I've got one option and I have to choose that one option. For the remaining 2 die, I need both of them. So out of the 2 die remaining, both of them, so 2 choose 2, must match each other. What they must match each other is already given. It's determined. It must be a 6. So only one option, that being the 6, I need to choose that option. Again, out of the denominator of 6 to the 3rd power, gives me the probability of having 2 6s and a 5. Finally, what's the probability that someone observes a pair? Okay, so what I took a pair to mean was that 2 die match each other and the other does not match those original 2. Out of those 3 die, then choose 2 of them to match. That's 3 choose 2. And I've got 6 options for those 2 die to match. So any of the numbers 1 through 6, and I'll choose one of them. Okay, I've got 1 die remaining that must not match the other 3, so 1 choose 1. This is the non-matching. They only have 5 options, seeing as they cannot be the matching option here, so there's only 5 options. I'll choose one of them. I get 2 that are the same, I get 1 that is a single, and I divide by 6 to the power 3. That is somewhere around 42%. Sorry for that little typo here in B, but maybe it was a happy learning experience.